All right, today we're doing combining like terms. Now, combining like terms is one of those things that once you start in pre-algebra or algebra, you really never stop doing it. So it's important to get the basics down at the beginning. So some of these problems may look a little bit challenging, especially if you're not used to dealing with variables or exponents, but it's actually a lot easier than what it may first appear. So today what we're going to be doing is we're going to start here with the basics, this very first problem. We're going to talk about how we're going to do it, what we need to look out for to be able to combine like terms, what makes terms like, why are they alike, and when can and when we can't combine them. And then we'll kind of work through some more challenging problems. I'll talk about what to look out for to make sure that we don't make some common mistakes. And then hopefully by the end of it, you'll be a master at it. So the first problem we have here is 4x squared plus 2x squared. Let's scroll down here and have a nice blank sheet so we can work on it, and we'll walk our way through it. So first thing, we need to talk about some stuff so we know the terminology. So this whole entire thing here is what we call an expression. Now, an expression is made up of terms, and we're obviously on the lookout for terms that are alike. So let me break this down a little bit farther. And in this particular expression, we have two terms. So terms are usually broken up by plus or minus signs. So here we have our first term, 4x squared, and our second term, 2x squared. And this is telling us, obviously, that we need to add them. Now, when can we add or subtract terms? We got to have like terms. So what makes something like? Well, we need to have the same exponent. Sorry, let's get back to that in a second. We need to have the same variable, which is the letter. And we also need to have the same exponents, which is that small number above the variable. So it can't just be one or the other. It's got to be both of them. So for terms to be alike, they need to have the same variable and the same exponent. So in this first term, obviously we have x squared, and in the second term we also have x squared. So that satisfies both needs, so we're able to combine these terms. Now, how do we combine these terms? Well, what we're going to do is we're going to look at this big number in front of the variable. We call this big number the coefficient, and all we need to do is add these, or whatever it tells us to do. This time it says add, so we need to do 4 plus 2. 4 plus 2 is 6. Now we're not quite done, but we're just about done. We need to take whatever our variable and exponent is and just throw it on at the end. 6x squared. And that will be our simplified form. We're all done. Now we'll point out a common mistake at the very beginning is students will also add the exponents, and they'll put their answer as 6x to the fourth, which is reasonable. It has plus sign. We see numbers. We just want to add whatever we see. But this is not going to be correct. And let me tell you the way I used to explain it to my students when I taught algebra. So let's think about it this way. Instead of 4x squared, let's call it 4 pencils. All right. And then somebody gives us 2 more. So we're going to add 2 more pencils to our collection. So how many pencils would we have? Well, we would have 6, and it would still be pencils, right? So the pencils are going to stay the same, just the same way as our x squared always stayed the same. So we don't want to touch the variable or the exponents. The only thing we need to do is add the coefficient. So again, even if we don't like dealing with variables and exponents, really all we're doing is looking at them. The only thing that we're actually adding or ever subtracting is just numbers. So hopefully this is pretty straightforward. Let's go down to the second one, and we can kind of highlight more mistakes that crop up in these type of problems. So again, I'm going to kind of isolate each term. This time we have 3 different terms. As you can see, we've broken it up again with plus, or this time we have a minus sign. And then we can see which terms are alike. So in each of these, we have an x is our variable. So that's good. And if we don't write an exponent, right, there's no exponent up here, we just assume, or we know that it's x to the first power. So again, we have the same exponent and the same variable for each of our terms. So that's good news. We can combine these terms. And if we combine them, again, we're looking at the coefficient. So we have 8 here. We have a plus sign, so I'm going to write plus. We don't have a coefficient here. And just like the exponents, if we don't have a coefficient, we can just assume that it's 1. So we have 8 plus 1. And then this little tricky minus sign is where 50% of the problems occur with this stuff. Students see 8, 1, and 4, and they just say 8 plus 1 plus 4 and get 13 as their answer. But we want to subtract this 4x. If you think about what I was saying before, we have 8 pencils, then somebody gives us 1, and then somebody steals 4 of them, so actually taking 4 away. So 8 plus 1 is 9, minus 4 is going to be 5. Let's not forget our variable. Our answer is not 5, it's going to be 5x. And that will be our nice simplified form. All right, so let's go down to the third one. And this time we have some terms that are not alike. So we have 4 different terms in this variable. 4 different terms in this expression. And we can kind of go through and highlight the ones that are alike. So in this first one, we have x squared, then we have x, then we have x, and then we have x squared. Even though we have the same variable, this doesn't have the same exponent, so it's not going to be alike. I'll take my orange highlighter and highlight these. So the ones that are highlighted are going to be alike. If you like the colors, I would recommend doing that. If the colors bother you, then you don't have to do that. And then if you want to, you can rewrite them to make them next to each other. So 5x squared plus 2x squared plus 3x minus 2x. So now all of the terms that are alike are next to each other, but this isn't necessary. I've been in some classroom where teachers like their students to do this. Personally, I don't think it's necessary. And it kind of can cause errors because, again, if we forget our negative sign and put a plus 2x, then we're going to get the problem wrong. So it kind of just creates another step where we can have unnecessary errors. But if you like this, you can do this. And then again, we're just going to take our coefficients and do whatever it tells us to do. Since these were alike, we're going to do 5 plus 2 is 7. And then have our variable and exponent at the end, 7x squared. Then we got positive 3 and minus 2. So 3 minus 2 is going to be positive 1. We'll just do plus. Again, we don't write the 1 if it's a coefficient of 1. So we're just going to write x. So 7x squared plus x. We're good to go. On to the next one. And now this one, we have some variables that look a little bit funny, but it's going to work exactly the same way. So it's no problem. For this first one, we have xy squared. So we're going to do all of it. But we need a term that has xy squared look exactly the same. So if we look at our second term, we just have an x. If we look at the third term, we just have a y. And our last term, again, is xy squared. So those terms are going to be alike. So what are we going to do with those? Well, we have positive 2 here, positive 3 here. So 3 plus 2 is going to be 5 xy squared. Again, this just stays the same. Now we have something different because we have an x and we have a y. And this kind of bothers me now that I'm looking at it, that was green while the other ones were also green. So I'm just going to take some different colors and underline them. So we have the x and we have a y, and we don't have anything that looks like them. We don't have any matching variables. So all we need to do is just add it to the end of our problem. We're just not going to combine it with anything. It's just going to sit there. All right, nothing needs to change. And this will be the final simplified form. Easy enough, hopefully. Now, before we're done, there is one important thing that I want to point out. Let's take a look at this up here. At the beginning of the video, I said that we need to make sure we're looking out for the same variables and the same exponents. Now, if I had this, and then let's say I had plus 2x squared y, technically these have the same variables and the same exponents, right? They both have x and y, and they both have squared, but these would not be like terms. Not like terms. And let's explain why that is. Well, if I look at this and I kind of break it down, I'm doing 3 times x times y times y. Remember, this exponent of 2 tells us to multiply y by itself twice. And over here, I would have 2 times x times y. So even though we have the same variables in the exponent, the location of the exponent in the term matters. So make sure you keep an eye out for that. Make sure you don't get tripped up on that. You'll likely probably see something like this where they've kind of moved the exponent around. So just remember that where this exponent is at matters. If we look down here, we can see that these are not the same. So again, these are not like terms. So keep that in mind. All right. Hopefully all of that made sense. If not, you can go down into the comments and leave any sort of questions you have. This is also my first video. So if you have any suggestions, you can also leave those down in the comments. Some people may like longer explanations. Some people may like shorter explanations. Let me know what you think down there. And if you would be so kind as to leave a like and subscribe, that would be awesome, and that would help me out. I appreciate it, and I will see you all in the next one.